Hey guys, so this is part 2 of the tutorial on how to make the Drawbot, and if you haven't seen part 1, check that out. But before that, if you haven't seen what the project itself looks like, then, well, check out the video on that. It's going to be in the description and pinned comment. So yeah, let's continue from where we left off. So right now we're getting into the more juicier stuff, the stuff we can actually see. That's going to be in app.py. But before we get into that, let's just create the JSON file we were talking about all video last time. So it's just going to be a dictionary basically with the platform. I'm just going to name it Roblox. Oops. Keep using single quotations. It doesn't have to be Roblox again. Like I said in my last video, it can be named anything. We're not switching between platforms or anything like that, so yeah, you don't have to worry about that one too much. Image path can be empty again for now. Oh, I don't have a comma, that's the issue. There we go. Then empty. And then distance can be 1. Keep forgetting my commas. There we go. And then delay milliseconds can be 1. Move delay can be 0. We're just copying everything we wrote in the program, so not much thought to it. Keep forgetting my commas again. Set it to true. And then we're just going to have a default mode that goes from small to large, 0 to 9. Talked about fast mode a bit before. And we just have that on at all times just because it's better. Then safe strokes, which is also true. Hex color count, just 12. Resize mode is fit. Position mode center, and transparent color is going to be white. There we go. And now we can finally go to app.py. So let's import threading. I think we didn't use threading in Drawbot.py, but we will be using it now. Let's get time, collections, should be a from. I'll just write them down and then give a short description of what they are. And yeah, we do need to pip install that. So let's go ahead and do that. Requests. So yeah, while that's happening, I'm just gonna tell you guys what these different modules are. So threading, as I told you before, runs the mouse execution stuff without freezing the Drawbot window, and time allows you to wait, and then the counter can summarize how many instructions of each kind are going to appear in a preview, and then the path is going to locate the Drawbot settings and the calibrations and the captured images and just their path or the location of it in your computer. And then URL parse is going to let one image field accept both local files and web addresses. So yeah, that's quite useful. And then requests, we're going to use requests to download the original image from a URL address as well, which I think is quite neat, even though I did not showcase that in the video, but it's a nice addition. And then tkinter is kind of the main thing we're going to be using because that's what lets us see the Drawbot window and its buttons and stuff. So that's kind of main thing for a UI. Pillow, I think I explained what that is before, and we just need a few additional things from tkinter. So file dialog lets the user choose the original image. Message box allows the program to show the user things like errors and stuff, and TTK allows a few interface controls. So we can also have everything imported from Drawbot. I don't know why I named it that. Just like import everything from drawbot.py. So yeah, we can start with the app's title, which I'm just gonna make Drawbot, and then let's have some paths. All right, let's first resolve like the main thing, call it root. It's kind of the main place everything else. And then from there we can go to positions.json, and then we don't have positions.json, so we won't be needing that. Settings.json. And also the captured image, which we're going to have later, of course. So capture path is going to be captured.png. So yeah, now we can go back and make a class for the Drawbot app this time, which is going to be what contains the interface and the button clicks and the core of the drawing engine. So yeah, this is kind of the interesting part if you've been waiting for some substance until now. So root is basically the main tkinter window that will contain the interface, and just do that, and then title it with the app title, and then set a minimum size so that things aren't just too tiny ever. And we're also going to just set a closed behavior to avoid it from having any malfunctioning later. So it basically just aligns with the Windows close event. And now we can load the presets in every saved, calibration that we had. So self.presets equals load presets positions path. We don't have presets, never mind. That was from something else. We need to load the settings though. Settings path. And yep, there we go. If we're not gonna have different platforms, but just in case we do, then we're gonna make sure that if a saved platform no longer exists, then it's gonna select the first available calibration. But I think that's quite optional to do, so let's just move on with the actual stuff. So we're gonna have the source image as none for now, because we don't have the image yet. And then the plan can also be none. And the preview photo that we often see can also be empty for now. And then the stop event can be threading.event to make sure it can occur independently even when different processes are occurring. And now we want to enter variables to connect the visible controls to these values that Python can read and change. So we can go ahead and do that, and then we can have the status string appear along the bottom of the window like you probably saw. So it's going to be like this is where it's going to show how many strokes it's done and update. So yeah, this is standard tkinter syntax where you can have a value which basically whatever you write in value is what's going to be shown. And I think it's a pretty decent system for having UIs with Python. And then we can build the UI and load initial image. So these two, build UI and load initial image, we are yet to define. So let's go ahead and start doing those now. So build UI is going to have style, which is going to be calling upon the style manager TTK. And then it's going to use the clam theme because I thought that one was pretty good. Oops. So this is just some tkinter stuff, which if you are familiar with, hopefully makes a bit more sense to you. But yeah, these are just UI stuff. So yeah, I think it's a bit more interesting now because it's the stuff we're making, the stuff you can actually see on screen. So padding, we're going to add some padding, and that basically determines how much spacing there is between objects. And now outer is going to be the frame that contains every part of the application. So again, we're just designing the UI here. I think this is a place where you can get a bit creative and make the UI look cooler or something different to your liking. I think Tkinter is quite intuitive to use. So this is like sticky, lets you anchor like stuff on the screen and things. So yeah, I think it is quite nice to play around with. So we're just making sure we place things in a way that looks good. And then we need to also do that for outer, which is our large frame. Oops. And now we need to have the frame for the controls, while the right frame is gonna have the image preview. So you know how the UI is kind of split into two parts. So that's what we're gonna deal with here. So the grid function is basically a way to place things on the screen in Tkinter. And 0, 0 means it's going to place on the top right. And pad X is basically just the horizontal gap that it leaves between objects. And then we're going to have preview as another frame for the right side of our UI. And then this time we're going to have row 0, column 1, so that keeps it on the right. As well as our anchoring is going to be NSEW for the east to have it on the right. And then we can just make sure it looks good again. And now we can add the image controls to the left hand and, well, just have things on the correct side and just place everything. So I think this is a quite chill section of the program because we're just working on the UI. And we're going to have to, of course, define these later. So we're creating a label now, which is finally stuff we can see for the preview, which is just gonna say preview, and yeah, it should basically the label saying preview. And again, it's just some arguments that help it look good within Tkinter. Column span and things like that just determine how wide it is, column wise, how many columns it takes within the grid. And pad Y is vertical spacing. I'm only selectively explaining because it's just the UI stuff that makes it look good on the screen. So now we can have another function called section. And this is going to be creating a control frame inside the main display thing and on its border. So yeah, this will make more sense when you see it in the actual app. So title is basically the text shown around the frame's border, and parent is the Tkinter kind of container that receives the new frame. And then pack is, like grid, another way to kind of place things on screen. But in this case, instead of grid, pack is a better option. Now we're going to have image section, which we had before. So this image section is going to let the user provide the file or the URL or make a cropped screenshot, as you saw in the demo video, if you saw in the demo video, which you definitely should before making this. And then we can create an entry where people can type stuff. So again, just placing stuff. We're placing that entry now where we can type stuff. And then we're just creating buttons now, which allow us to browse a normal file picker. And we're going to be creating more functions later too. We're setting command to self.browse image, which we haven't defined yet. So we're basically just making it so that when we click the button, it's gonna call the function browse image, which is gonna open the browse image thing. And then we haven't coded that in yet, so we'll do that later. But right now we're just creating the buttons that we can actually see. So again, we're calling upon these things that don't exist yet. So, but that is no problem because we will create it later. We're creating all these buttons. One to open a normal file picker, one to hide the app and then let the user pick a rectangle, and the other just to read whatever is already in the entry. So now we're going to the calibration section. Which is where we can have the freehand select, that box part of the UI. So here's where we're using that section function again to create that section. So again, we're just making the UI, so I'm not explaining too much. Now we can place this platform box on screen. Now we can make changing the selection refresh the coordinate summary that's shown below it. So There we go. And now we can have a button that when we click, it activates the freehand selection mode. Trace canvas plus. And also, after that, pick the hex. So we can name that calibrate. And again, just place the button on screen. Oops, I just lost my cursor there. And also just have a label that shows the string containing the saved coordinates and the point count, just to let the user know that it worked out. So yeah, again, this might be familiar from, I don't know, like MS Word, justify left, and yeah, it's what you think it is. It just makes it left aligned, the text. Now we have drawing section, which is the section more towards the bottom that contains the image conversion and the instruction planning options. So again, create that section using our section function, name it drawing, and then we need to have, we're just going to let the user pick the distance. And then we want to add color control beneath distance. So you can pick the number of colors. And we're linking it to the appropriate variable. And now we want to have the user select the resize mode. Again, not much talking here because it's some UI stuff, just placing things on screen and making it look good. Feel free to get creative with this. Again, we had fit, stretch, and none. We have fit and by default, but in case you want to change it in the future. Now we need the timing section that allows us to fine tune the timings, like the delay and things, in case things don't work out for user or they want things to work faster. So yeah, let's go ahead and do that. Again, just a bunch of UI stuff. I just realized these are more indented than they should be. So yeah, let me just remove the indentation here. You can press Shift and Tab at the same time to do that. And yep, just more UI stuff now for the timing section. And we need to do this for all the three types of delays. So move delay and also color delay. You're setting the range of values it should accept. And this should be 100. Yep, there we go. And now we just need the final section, which is the run section. And this section just has the the preview planning and drawing and stopping buttons. So this button allows you to preview plan. Just gonna copy paste this to save some time. This is going to be to draw. And oops, this should be preview plan. This should be row 0, column 0. And we don't need this padding. And this one, I think, is correct. And then the final one, which is to stop. Just let the new user know that we can either press escape or Q to stop, and then we can hook it to the stop function that we'll write later. And this can be row 1, column 0. We also want to make this a bit wider, so column span equals 2. So occupy more space. Now we can define add number control that we used quite a few times before here. And all that does, all that's going to do is just label a numeric box and then return the next free grid row. So it kind of helps out with arranging stuff in Tkinter. So let's go ahead and write that. It's going to make a bit more sense when we actually write it down. So we can create an integer variable and store where its settings collection can find it. And then next we can just place a text label in the left column and the numerical control in the right. So let's go ahead and do that. So again, just to help out with some UI stuff, we've got this function. Then we can create a spin box. Oops. Put a comma there. Not sure why that is. Okay, yeah. I think it's a Tkinter syntax thing. It's a bit strange. And now we can return row plus 1 And next, we want to load the initial image, which is just going to try to load the image that we upload or take a screenshot of so that we can see that it got the correct thing in the UI itself. So let's go ahead and do that. And the path is going to be the image path .get, and we want to get rid of any white spaces from the start and end. And we need to be able to account for if the path is empty. So if path, then we try to avoid errors. We're going to try to return the pillow image. And then show it on screen. Not sure what the error here is. Okay, it's going to resolve when we do that. We'll put that in later. Just going to show the image, and then it's going to just let the user know that the image has been loaded in. And then in the case of an exception, we can say that it saved an image. I mean, the saved image couldn't be loaded, so saved image could not be loaded. And perhaps tell the user to choose another image. And now we need to write the function to let the user browse for an image on their computer when that specific button is clicked. So browse image. And first we need the path to be what the user picks. So we need to ask open file name, and we need image files to be allowed. So it's going to be images, then for example .png, .jpg, .jpeg, .bmp. These are all image files. A GIF file and a WebP file, or the all files option. And okay, file type. I think I'm missing something. Yeah, this needs to be inside of a list. Yep. There we go. And now we need to account for if it's empty again. So basically, it's gonna receive the path and replace the text that's shown in the image path entry. And yeah, and then it just loads the image. And then the load image is what we're going to define next, which is, well, gonna load the image. So again, we want to avoid errors, so we can use try again. So it's gonna receive the path from the entry and then return the RGBA pillow image. And then it's gonna show the image. Well, yeah, we're loading the image, so we're gonna show the image here. And then give the message that loaded self.source image.width and then basically the dimensions, we just want to show that to the user for their information. And yeah, now dealing with exception. We show a message box. This is what we imported specially from Decanter before. It's going to open a message box. It's going to say could not load image with there. And next we want to be able to read the image, which is basically allow us to upload an internet image URL and also still get it. So yeah, for this we're going to use the URL parse library, and I think this is a pretty cool addition to our project. So here we're going to parse the text so something like HTTP and HTTPS can be distinguished from the drive letter paths. So it's going to distinguish it between an internet URL and something that's from your computer. And also we're going to add a timeout to make sure it doesn't load forever and eventually tells the user that it's struggling to load. And we need to convert any HTTP errors into normal Python errors. So we can do that by doing this. And then we need to also get another module here called bytes.io, which is going to let Pillow read the downloaded bytes as if they were just a normal file. So we can now return the content and convert it to RGBA, which allows Pillow to work with it. And otherwise, it's just going to return it's just going to open the local path and then standardize it to the default 4 channels RGBA. So yeah, now we're going to let it make the freehand crop. So capture screenshot. So now it's going to withdraw from the decanter window and update. It's going to wait for a sec. And then it's going to capture the full desktop as one image. So screenshot, image grab, and then on top of that it's going to overlay whatever the user drags. So self dot selection overlay screenshot, and then we're gonna ask it to drag around the image. Let the user cancel as well. Then we're going to hook this to another function, which we can define over here, which is finish capture. So here is where it's going to crop the screenshot to a box and then save it as, the crop, and then update the preview. So screenshot is the full desktop image before making the selected crop, and then box is what contains the left, top, and right and bottom crop edges. So first we need the source image to be cropped, convert it to RGBA again, and then we're going to tell the Pillow module exactly where to write this crop. So capture path is where we want to put it, and then we want to update the visible path and preview and status to match the new image. So after that's done, it's going to say that it captured. Just to let the user know that things are working. And now we want to get fresh positions for the canvas and the hex field. So that's going to be in calibrate, And then again with draw first and update. Again, takes a whole screenshot of the entire desktop. And then we're going to be calling upon another function, which I'm going to explain right now actually. So what this is going to do is it's first going to trace the paintable shape, and then it's going to record the color text field. So basically, the screenshot is the entire desktop image shown behind the calibration tools. So within this, we do want to get the outline, the traced point pairs, and just create a list of all the points that's going to be traced. So def outline done. Points. It's going to be mask equal kind of a list of, a tuple of x and y points. And then we need to save the selected hex field point with the traced canvas calibration. So a click can be defined as follows. So again, we don't have multiple platforms, but just in case we do account for that over here. And then also reuses the calibration that's already there. And now we want to replace the rectangle and hex point and freehand mask. So let's go ahead and do that. And now we want to write every calibration so that even though it's restart, it still saves. And we're going to save this in another JSON file, which we can define now. I think we have to go back for this to where we had these paths. Positions path equals root divided by positions.json. which gets created there. Let's go back. Where are we now? Yep. So we can now do that. And now close the full screen overlay and bring the window back. So we've now taken the freehand screenshot. And we can let the user know as well. Save trace canvas for name. And then the list of points can be told to the user to let them know how many points they identified, just to let the user know that everything's working properly. And now we want to show the screenshot and send the selected hex field point to be clicked. So click overlay, screenshot, and then click center of hex field. Oops, yep. Escape cancels. And then this is going to be linked up to the click function. Now we want to use the screenshot as the tracing background, so you can go ahead and do that. I wonder what the error is. Okay, we didn't close the string. That was an easy fix. Yep. And we're gonna link this to that function and not restore the root. So now we can define the freeform overlay that we just used. And what freeform overlay does is let the user make a freehand selection, which records the canvas outline while the user holds the left click button. So what this is doing is it builds the screenshot overlay and also obtains things like its coordinates and scale factors. And then we can store all the points and the last point that was visible during tracing the line around the character. So now we want to clear any previous attempts at making the outline. So let's go ahead and do that. And now we want to define drag, which draws a kind of cyan colored outline around where you drag your mouse just to make things more aesthetic, and also reassure to the user that it is registering the region that you select. So if you watched the demo video, you'd understand what I'm talking about right now. So basically, we're ignoring any motion here that has occurred before a valid press. And now we want to draw the cyan line. So we can do canvas.create line last 0, last 1, point 0, point 1, and fill it with some sort of cyan color. I think a good hex would be 00E5FF. Yep, that is cyan. And just additional stylistic stuff for the line. And we want to make this point the start of the next visible segment. So we can do that. And that lets us draw our beautiful cyan line around the character. And now we want to release the finished outline and convert it all into a full screenshot of coordinates. So we can define release. And then we need at least 3 points again, so I'm just going to account for that. If it's less than 3, it's going to return nothing. And again, it's going to include the exact release position of the final point. And then now we're going to scale every displayed coordinate back into its screenshot coordinate. And we want to do this for X and Y in points. So now we want to close the overlay and restore the main window. So overlay dot destroy, and then now restore the window if the conditions met. And then we want to send the completed screen coordinate outline to the function that called it. And we also want to route the mouse press and the drag and the release events to some functions. So let me just write that down so it makes sense. So next we want to find the rectangular bounds needed to position the trace Drawbot canvas. So yeah, let's go ahead and do that. So for example, for bottom, just finds the lowest screen Y coordinate in the traced mask. And then it returns the top left and the bottom right coordinates. And now we want to create a rectangular section which is used for choosing a source image from a screenshot. So let's write that down. Need self screenshot prompt finish. And basically screenshot is the background image and prompt is instruction text, and then finish is just the screenshot that it receives and also the selected crop box. So yeah, it will make a bit more sense when I write it down. And now we want to define a press which begins a new selection and creates a cyan rectangle. So this is basically to be able to crop the image. And then we can select the color again. I'm going to choose cyan hex. And now we need to define the drag, which allows us to drag from the top left to bottom right. So yeah, it just basically goes from the start point to the cursor position until it lets go. And the let go is going to be release, which we will write down later. But for now, let's write the code for what happens when we're still dragging our mouse while having it clicked. And the release is going to validate and then convert the selected display rectangle. So we're going to ignore a release that didn't have any valid press. So if not state start, then it's just going to return nothing. But we also need to make it so that it allows for dragging in any direction and not just down and right. So let's go ahead and do that. And we also want to ignore any accidental clicks or some sort of rectangle that's way too small to form an image. So we're going to just account for that like this. If it's less than 2, it's too small to return nothing. And now we want to convert these overlay coordinates back into the original screenshot coordinate. So let's go ahead and do that. Now we can close this overlay. Oops, wrote distorted there. And then restore the screen. and then send the screenshot and the selected crop edges to finish capture. And now we want to, again, root the mouse pressing things like we did before. Yeah, these 3 lines can go here again. So now we want to display the screenshot and also pass one scaled hex field click just to get things working. So let's write that down. So here, screenshot is the background image and prompt is its instruction text. And then callback is just receives the selected screen point and overlay window. And now we can convert the click to a screenshot coordinate before we can pass it to calibration. Now we can do this for it's basically receiving the left click event name for Tkinter. Now we want base overlay, which is basically just what builds the actual full screen screenshot and the canvas that's shared by the crop and calibration tools. So we're going to have self screenshot and prompt again. And the width is going to be the actual screen dimensions of your computer. And now we want to link the temporarily overlay to the app. And now we want to remove any window borders and then keep the capture overlay above the game. So basically we're just making the overlay work. I think I forgot to close the bracket there. Yep. So what's going on here is that the resize is only done when the screenshot and the Tkinter screen dimensions are not the same. And that's why we've got the if statement there. Now we want to convert the resized screenshot into an image that Tkinter can display. So we can have photo and then we can create a borderless, just like a crosshair inside the overlay. So that's what turns our cursor into a crosshair, if you've seen the demo video. Then now we're just gonna place it. And now we want to place the screenshot at the canvas's top left corner. So NW keeps it at top left. And now we want to create some sort of black dark instruction strip, and we have that white prompt over that screenshot. So this is that section of, if you saw the demo video, it's that instruction black section on the screen. So let's have some sort of black color. Now we want the text to be white. So let's go ahead and do that. Now we also want to be able to close this mode when we press escape in case we accidentally activated it. So here we are returning the overlay, the canvas, and also both of the screen scale factors, vertical and horizontal. And now we have this self.cancel overlay, so we just gotta quickly define that. cancel. What does it mean by canceling an active overlay? And by that, we're just destroying it and restoring the window. And by restore root, we mean bringing it back. So it's just some decanter syntax and functions again. Oops. There we go. And now we can define preview plan, which performs all the actions before any before it takes over your mouse and stuff. So let's handle errors here to make sure. And then we can define make plan a bit later because that's a bit complex. And then kinds is going to be instruction kind for instruction and self.plan instructions. And then we're going to we're basically going to be counting each plan instruction type for the summary. So let's go ahead and do that. So here's the drag mode. So it tells us how many of each type of thing it does. And then to handle the exception, and then just show them a message box again. There we go. And now we want to define what make plan is, which basically returns the draw plan. Let's go ahead and do that. So first we want to try loading the path field automatically when there is no source in the memory at the moment. So if self.source image has nothing, then we can load it. And there's also the there's also the possibility that the loading may have failed, so we want to also account for that. Oops. And now we want settings from UI to be called upon. And we also want to find the calibration selected by the current platform field. So since we're not changing platform, this doesn't really matter, but it's also because we are allowing changes to occur, we need to do this. And now we want to make sure the preset being empty doesn't raise errors. So we're basically making sure there's a low chance that the program raises an error. Just stops working. We can save the settings now. And also, we want to return the things containing the image planning engine. So next, we need draw builds. We basically need to complete and validate the plan and then execute it as a background thread, so without interfering with any actions. So let's start doing that. So we want to ignore any repeated draw clicks while it's still working. So that prevents that. And then also we want to be able to build the plan and then retrieve the calibration that is used to position it. So let's go ahead and do that. Oops. There we go. And deal with the exception. Just show another message box. And if the prepared image didn't produce any paintable marks, then it's also gonna show an error box. Oops, I just clicked something. Yep, there we go. Now we want to clear any earlier stop request and minimize how much the interface. We want to minimize the interface before the program takes over the mouse, because we don't want it to start painting on the interface itself, of course. So let's go ahead and do that. So we're basically using worker and then threading to make sure Tkinter stays responsive in the process. And now we want to define what happens when you run a worker. So basically, this function is going to execute the plan after the game, gains focus. And by that, just like after it minimizes the window and stuff. And then it's going to restore the Drawbot window back. So let's go ahead and do that. So to reuse error again, and then we're going to wait for some time. We need to give the game some time to become the active window after the Drawbot UI is minimized. And then we can call upon the executor to be able to cancel drawing safely. And then to handle the exception, we can just say something like stopped with error. And then despite anything that happens, we just need to restore the window. So we can do that with finally. Now we just need to define a few minor things like stop, which asks the executor basically to stop after its current drawing action. So it just needs to stop the event and then tell the user that stopping after the current action. We can also have thread status to be able to communicate with Tkinter. So we basically send text to the status label on Tkinter's main thread. And yeah, that's good enough for this function. Next, we want to read every single visible control and return one of the validated setting objects. So this is going to be the settings from UI function. It's basically just going to return settings in platform. .get, and then image path, as that. Then distance as maximum between 1 and that. Then delay milliseconds, maximum between 0 and that. And same for move delay and color delay. And then we can set fast to true, safe strokes to true, hex color count to maximum between 2 and that. And then the resize mode can also be something similar. Finally, the transparent color, which is going to be using that. And I think we left these for now because they were kind of similar to these ones. So let's go ahead and fill those now. Yep. And this is going to be move delay ms and color delay ms. There we go. Now we want to define what happens when we call upon show image, which is basically just a function that fits the image into the preview area without changing its resolution. So we're doing that right now. So basically it's copying the planned image and converting it into RGB for the preview. And then we're just gonna fit the preview within 560 by 620 pixels without changing its proportions. So Go ahead and do that. Now we want photo image, which is a tkinter function, which can display the image. So self.preview photo equals image tk photo image preview. So basically, we're just receiving the preview photo and then replacing placeholder text here. Next, we can move on to the calibration summary, which basically allows the user to confirm that the positions were saved. Let's go ahead and do that. Now we want to find the selected preset or tell the user that calibration is still required. And we also want to format the saved hex field coordinate. Now we want to tell the user whether there is a freehand outline that's already been taken and how many samples it contains. Just gonna add some brackets there. And now we want to be able to combine the rectangle and the hex and the outline information into a visible summary to the user. There we go. Now we just need to, after calibration, refresh both the drop down choices and also, the active, whatever is actively selected, so we can have refresh platforms. It's basically we're refreshing the drop down with every saved calibration name. And then we want to display the new coordinates right after, so like immediately. Now we want, oh, okay, this should be not inside here. Oops. That was an accident. I was meant to click. Then meant to press Shift Tab. There we go. So now we want to define close, which brings the program to a, kind of a safe drawing stop, and then also saves the controls and destroys the window, just closes safely. So let's go ahead and do that real quick. So stop all events and try to handle some errors. So it only takes and returns the current validated settings and then saves it. And we never want to trap the user just because, one half edited control isn't working. So we've got this. And then we just want to destroy and, close. That means we want to close the event loop in the program. So let's go ahead and do that. And finally, we can, outside of the class as well, write main, which is just which starts everything. So root equals tk.tk. And then we call upon Drawbot app upon this root, and then just standard tkinter stuff. We have main loop. And then since we're not directly running this program and we're instead going to be activating it through a .bat file that we're going to create just in a minute now, we're going to have this statement. Right here. So all that's left to do, I think, is make the bat file and then debug this, because I think there's a couple of different bugs right now, like our last part. But let's just make the bat file before then. So it's going to be quite short, just the usual things that go into the bat file. So you want to change this into your projects folder. And yeah, it should be good. Let's get to debugging now, I guess. I think one thing is that we didn't load the presets. There we go. And okay, we also need to initialize the worker here, I think. And I think we forgot the equal sign here. I don't think this should be capitalized. Oh yeah, also, I think this one should have a weight of 1. Self dot. And also, this should have a weight of 1. Get rid of that. I think this is better off as NSEW. I think we're just good returning section here. Over here we have column twice. Should be column span instead. Oh, I think this should be pad Y. Oops, I think this should be 1. Or I think we didn't gotta close the brackets earlier. We wrote withdraw instead of withdraw. Okay, we needed points here. That's one reason why we got a lot of errors. Sackled should be scaled. We're missing this over here. Canvas dot create rectangle. And this should be destroy. And again, since we copy pasted, we have that issue here as well. Oh, I think these go outside of here. I think so. Yep. Count not start should be could not start. And also, I think there should be a return here. And also, we did not start the worker here. So let's just add that in. Self.worker start. And yeah, I think that fixed the issues. So yeah, once you double click run.bat, you can open this and capture screenshot. I'm going to be selecting the Mona Lisa, and then you can preview your plan by clicking that button there. And this preview should pop up. And I'm going to be using a website that allows you to enter hex code and also paint. So that's basically what any painting game of this sort has. So if it works here, it's going to work anywhere. And I'm going to do this freehand select thing just to show you guys that it works. And then click on the hex, and then we can click draw. So yeah, the preview is also going to update because we had a new region, and I think just got wider, but yeah, it's going to draw over the selected region when we click draw here. And yeah, that is phenomenal. So if you liked this video and found it helpful, please leave a like and subscribe, and I'll see you in the next video.